think we're good. Okay. Welcome back. Been a couple days. Been busy, as usual. Haven't had time to sneak a video in, but I'm here tonight, and we're going to work on a new one. So this one comes from Canada, eh? um, so we're gonna dig in and see what we can go, figure out and get this guy repaired. So let's dig in. So here we go. Here it is. Just brought out of the box. Haven't really messed around with it yet. Did a little looking, and there's a few things that are blatantly obvious. I'm sure there's some other things that we'll have to figure out, but let's get into it. First one is, the infamous Carly caps on the primary side, and this one you can see is just burnt to a crisp and blown apart. So that's one issue. The inrush as a whole burnt into it. This is a fairly large one. So what happened is this amp probably took a power surge. And the surge got past the inrush, and then it killed the Carly cap. Hopefully nothing else is severely damaged on it. Not a lot of glue on this one, which is nice. Should be a pretty straightforward repair. I like these amps. They're small. They put out a decent amount of power, and it's a pretty small package. Like, you don't really need a whole lot going on there. I wish the inputs were on this plate. They're not. But I have a harness that I made that I can put the inputs in. But this is the same input board that I believe the RSW-10D uses. Probably tuned a little differently on the processor, but the board is the same. The only difference is they get the audio from here instead of from up here with the LFE connection, and there's no speaker level inputs. But I'd be willing to bet that if I put some wires on there that those would work. So it's probably all there, just not configured to take inputs directly. It's configured for remote input. So whatever, we'll dig into that. Probably gonna recap the whole thing. There's not too many caps on here, and these are kind of at the age where they need to be redone. A lot of the newer ones, I'll cut some corners and just do the repair on the damaged section. But anything that's 10 years or older, I think you should get a recap. So I usually don't do international orders just because the shipping is kind of ridiculous with customs and all that, and I just don't like dealing with it. I can't just print a label out. I have to go to the post and do all the customs paperwork there, so I generally don't do overseas. But this guy was on the list, and he really wanted his amp fixed, so I said, alright, I'll make an exception and get you up and running. Wonder how things are going in Canada. I haven't watched the news lately. I do support the trucker movement, though. I'll have to look at that later when I'm done and winding down, see what's going on over there. I think a lot of us are fed up with COVID restrictions. I've personally had the virus twice, and I have a vaccination, so I have like zero tolerance for anything related to this virus. It ruined my, I've said before, it ruined my wedding. It's ruined my holidays. It makes me miserable at work. So I stand with the Canadian truckers. I think that vaccination should be a choice, as well as mask wearing and all that other crap. And mask wearing does not work, because that's how I got sick, even though I was wearing a mask. So I don't care what anybody says. I lived it. I suffered through it. I survived it. So can't say that I didn't, or, you know, I don't have my facts straight because I was there. Alright, first thing I'm going to do is just pull that Carly cap out and throw it away. Enough of the COVID talk. I don't want people to get all upset and start crying about it. It's unfortunate you can't really have good discussions these days without people getting their feelings hurt. It's kind of frustrating. But that's the way it is. So I said my piece. I will leave it at that. So I don't really see glue damage on this one, which is rather nice. The glue doesn't look like it's gotten anywhere where it shouldn't. I think if we just pop out these Carly caps, pop out this NTC, and then recap this power supply should come back up. I don't see anything on here that looks you know, bad or blown up yet. Let's see, any burn traces? No, no burn traces. Couple hot spots. That's pretty normal though. But nothing burned. This is kind of an interesting thing. It's like a hollow solder blob from when they wave soldered the board. There must have been some flux trapped in there and it just burst right before it hardened. It's kind of cool. But I don't see anything on here that freaks me out or makes me worry. I think this is just a cap related issue. So here we go. Let's get a good look at it. I don't know what's in these, probably toxic and gonna kill me, but that is just burnt to a freaking crisp. Good thing they use flame-proof parts in there, because that probably would have burned your house down. Let's see, make sure it's, yeah, it's one way, it's going right in the garbage. I've been using this new solder tip lately. I think this is my new favorite. It's like a stubby, high heat version. Works really well though on smaller leaded parts. I don't know what the pad rip-off threshold is for this. I haven't put enough time into it yet. Hopefully it doesn't destroy pads for me. Let's see, we're gonna take out the two Carlys and the two big boys. I gotta change tips for the big boys. Yeah, this won't fit on them. Guy's gonna be hard to get out. He's like buried in there. Alright, let's see, we gotta get the cap that's by the power supply is almost always bad. So it should be replaced. If I can pop it out of there, we'll measure that one. But this 47 is almost always bad. It's in a terrible spot. They get hot. They're cheap, the cheapest of cheap caps. This one usually has to go. Sometimes you get lucky, but I'm not feeling it today. Well, it's better than some of them that I've seen, but it should be 47 and it's reading 31, so its life has passed. Alright, let's see, we gotta get the inrush out. I don't know if this tip will do that one. Let's see. It will. Barely. Barely, but it worked. At least I think it did. It didn't clear the holes that well, but I think we can get them out of there if we play around a little bit. So yeah, that guy's cooked. 4 ohm 8 amp on the inrush. It's a pretty common one for Klipsch. I don't know if I'm going to go through this whole repair tonight. I might just do the power supply because I do have to be at work early tomorrow. I have meetings. Lucky me. But we'll see how far we get and how long this takes, and we can always stop and continue. Oh, that's not the right one. I need the big boy. I need to order a new one of those large tips. I was getting them on Amazon for a while, but the seller stopped selling them, so now I gotta pay ridiculous prices and order them through distributors. Kind of sucks. It was nice being able to get them cheaply. Or get them cheap. Cheaply made and cheap. I don't think they were OEM. I think they were like aftermarkets. So Weller might have stepped in and shut them down. It's very possible. You know, if they're not getting $45 for their $3 piece of copper, you know, somebody's in trouble. So that's my gut feeling. Whether or not I'm right or wrong, I don't know, but I'm gonna say I'm probably right. It's probably shut down. So we did have a little bit of shorting under that cap. I'm gonna guess that was due to the casing of it melting, and then it probably got to the board and did a little bit of damage there, but nothing. I mean, I can go right over it. I don't have to do any repair. It's just, you could see that an arc jumped between the pad and this ground plane that's on there, or power plane, whatever it is. Nothing serious though. Nothing that worries me. Glue is nice and crispy, so don't really have to worry about that too much. The glue should come off. Alright, so far so good. Let's see what we got here. So our bleed off resistors that are mounted in there nice and weird. I might just leave that one. But I do got to get the Carly cap out. Those got to go. I do not trust these at all. Not on this side. You know, to the power side of the heatsink, I would say replace them. After that, they're okay. I don't know why they don't do well on this side of the board, but they just don't. So I've decided it is in my best interest to just replace them and not worry about, you know, the extra cost. The glue's not too bad on this one. It hasn't like fully hardened yet. It's crispy, but it's not like bad. Can actually, this is the perfect point of glue to do a rework, because I can scrape it off without you know, having to put heat on it. And it doesn't make like a huge powdery mess, like it comes off in chunks. So that's pretty good. You could use heat if you want to, it just makes it come off easier, but I don't really see a need. Everything's cooperating so far, which has me mildly terrified. That means that something tragic is going to happen as soon as I get this thing powered up. Alright. Well, the glue is off in the major spots that I would worry about. A couple little pieces by this ceramic cap. And again, you know, if it's touching the parts, it's not the end of the world. You just want to make sure that anywhere where it could cause a short is cleaned out. You know, a little bit of glue on the board isn't going to hurt anything, but if it's touching two different traces and it burns through the trace for whatever reason, you're going to blow the amp. And then you're going to be mad and have to probably take it all apart and rework some of it. So I am getting low on capacitors. I'm not going to lie, that's terrifying, because when I run out of capacitors, I'm going to have to shut down. And everybody that's on the waiting list is going to be upset with me. I've been struggling to get a lot of the parts that I normally use. They're just not available right now. It really sucks. But there's nothing I can do about it. I just can't get them. Companies like, you know, GM and Apple and, you know, whoever else uses, you know, big caps in their devices, they're going to get them way before I do, so keep that in mind. If you're on the waiting list and I run out of parts, I apologize, but I can't help you. I have one guy who sent a plate in, and his amp needed a special cap. I can't get it till June. So it's just got to sit here till June. I mean, he said go ahead and hold on to it. I want to get it fixed, but he's got to wait. It sucks. Totally sucks. So recapping the primary side right now, I'm just going to go through this one section at a time. Pull the bad ones out, pop the replacements in, solder them up, and then move on to the next section. I'm not even going to bother powering it up until everything's done. That way I can at least rule out, you know, all the caps on the other side of the board should something else be wrong. It's generally uncommon for that to happen, but you know, it does. Sometimes you do get cap-related failures on the other side of the board. So it's, if you replace them all, you can know for certain that you know, it's something else that's causing the issue. Ninety percent of the time, though, on this style of power supply, just recapping the line side will most likely get it back up and running. It will repairing the line side. I don't want to say just recapping, because you got some parts in there that do need to be replaced. And just for the hell of it, since I got my meter already out, I want to see what these little Carlies say. That one tests good. I might throw these back in my drawer if they test good, just as an emergency supply, because, you know, I'll use the blue ones, but just in case if I can't get one, doesn't hurt to have a few originals laying around. Both of those did test good, by the way. They're supposed to be 0.1, so. Alright, I needed an inrush limiter. Running low on these things, too. I should be able to get these, though. I don't think these are affected by the current component crisis. Capacitors are the real big thing. Just getting caps is getting hard to do. I mean, it was difficult before, but it's getting worse. That's the problem. Alright, let's do a little lead trimming. We got to throw the one electrolytic in there. Actually, the rest of the leads are pretty good. We're just going to leave them. So we got one 47 at 50 volts. Make sure we throw a good high temperature rated cap in there. This one's, I don't know, the old ones were 105? No, the old ones were only 85C, so I'm putting 105C in there. Much higher temperature rated. I don't know why they put this cap right next to the heatsink and right behind that control board that gets hot. You could have moved it literally anywhere. I'll be honest, I don't like this cap back in here on this. It's right up against the pins on the back of that control board. I'm going to put a little bit of an offset in there. I don't normally do this, but on this guy I think it's necessary. I don't want it rubbing up against them pins, because it's just going to puncture a hole in the side of the can. I still don't like how that fits in there. I guess I could leave the legs a little bit longer. Of course, you know, it's way down in there where it's impossible to reach and actually move around with your fingers. I think they do that on purpose sometimes, just to, like the guy who's laying out the board laughs, like someday somebody's going to see this in here and curse my name. Let's try that. Tack it in place and see what it looks like. I'm going to have to silicone this in. There's no way around it. I do not want that vibrating against the board. I'll zoom in here once I get my head out of the frickin' way. Give everybody a peek at what I'm talking about. Totally unnecessary to pack that in here this tight. So I'm looking down in here. There you go, you can see it now. And back inside there, there's the pins that are on the back of this board here, and they're poking like right towards the cap. You can kind of see them down there. I don't need to zoom in, you can see it, but here's the clamp right here that holds the MOSFETs in. So the cap's just like sandwiched in between that and then these sharp pins down here. Pretty crappy way to set that up, if I do say. But I'll fill it in with a good amount of silicone on both sides of that cap, and that way it'll be sandwiched in between something soft. There's really not much else you can do over there, unfortunately. Let's put the big boys back in, 680s. That's another cap that's getting hard to find. 680 at 200 volts. Got some shorties. Shorties will work just fine. I don't really like how these bleed-off resistors are sandwiched in there either. That kind of gets on my nerves a little bit. You know what I'm gonna do? I'm gonna make a modification on this one. I'll tell you why. I don't want I can't remember if they were all like this or what. I don't want this resistor touching the brand new cap. I want to give that cap a chance at a good life. So I'm going to move this resistor to the bottom of the board. It won't hurt nothing. Just a way to do something a little different. Since this is going to Canada, like, shipping's not cheap. Maybe it'll give it a little bit better of a chance to survive. I mean, it's going to survive anyways, but my rule is you should be able to get a minimum of 10 years out of any repair. If you get 10 years, you did your job correctly. If you get less than 10 years, then I'd question it. But what we can do is we can put it in there and make sure it's above the standoff height, and just put it on the bottom, and that gets it away from the cap. Now, it'll still dissipate heat, so there'll still be some heat there, but it's not going to be laying literally right up next to the side of the can and just cooking it. So I mean, maybe it's a little bit OCD. You probably don't have to go through that length to do this, but you know what? It's something I want to do, so I'm going to do it. This is my repair. I'm the boss. tips and tricks, you know. So there we go. Just move it to the bottom of the board. It's well within clearance of the heat sinks. It's not going to touch or rub up against anything. But most importantly, our brand new caps are not going to just get annihilated by heat trapped in there. And that's good for the control board too, so there are benefits. I'm not just doing it to do it. Alright, check our polarity on our mains. Looks good. Let's get them soldered in. I'm gonna back solder these two. Make sure we get a good fillet on there. These traces are kind of fat, so they do suck some of the heat out. There we go. That ain't going nowhere. Use the solder sucker to make sure I get plenty of heat into the tank caps. These fat traces, and there's planes on the other side of the board too, so they do draw a decent amount of heat. Doesn't hurt to go in there with the big boy and make sure they're fully wetted in. You don't have to do that, but I don't know, a little bit of extra peace of mind, I guess. Okay, now we got to pull out this one. And, well, you can, I guess we do have a little bit of crispiness here. You can see the, at some point the resistor was getting, you know, hot. And you can see the cap is directly affected by that. There's like, or you can see it there, there's like residue on there from where it was like burning the plastic. And we have a little bit of indications of some shorting down here. So there's some corrosion on this lead, and the glue is really almost blackened right by that edge. So if this section here hasn't failed yet, this glue was about to cause a failure. So that's got to go. I always try to give the cap a little bit of a pop first so I can get some air under there. If you can't get air underneath the cap, sometimes it's really hard to get it out because the solder sucker has nothing to pull the solder through. So let's there you can see the mark on there a little better. I don't want to zoom in, I'm being lazy, but that like streak that goes across, that's like burn. I wouldn't say that was a fire risk, but definitely an amplifier risk. Alright, we'll get this glue out. And if you want, you can leave it on the standoff. That can stay, but everything else around that has to come off. Except for your fingers. Don't take your fingers off when you're trying to do it. So if you just want to shave around that and actually leave it on there, that's perfectly acceptable. I generally don't glue standoffs in when I replace them, but you know, it's up to your discretion how much you want to leave on there. You just can't leave it on there anywhere where it's touching traces. That's the only rule. It's going to cause a short, it's got to go. The glue over on this end was a little bit more flexible. I was still able to pick it off without heating it, but it was not as crispy as the glue on the front, which is interesting because it was about to cause a failure up here, but it seemed to be in better condition. That's it for the glue. I mean, this is a pretty nice one to work on. Really nothing that, you know, would drive me nuts. I am going to switch out soldering tips, and we're going to start doing all the little caps now. We got 6 of them, I think. Let's see, 2, 4, yeah, 6. 2 100s and 4 47s, I believe. These guys generally are still within their tolerance, but you know, if you leave them in there, you're kind of playing Russian roulette. You know, like eventually they're gonna fail. You just don't know when, so you might as well just take them out now. All right, let's change my solder tip. Get those out. Let's see, we're at 12:06. I gotta keep track of the time. Like I said, I don't want to stay up too late tonight. So far, the new tip has still been serving me well. Okay, let's see. So apparently there were some other control stuffs in here, different circuits and whatnot. I believe that this exact amp is used in like some JBL or maybe Harman Kardon. So different manufacturers have different features populated into the boards. I don't really know what any of it does. I never researched it enough. I just know that multiple subwoofer manufacturers use this exact power supply in their designs. I think the only thing that's unique to Klipsch is this feature board right here. I think this is Klipsch design board, and the amplifier board and the power supply are is this Indigo? Yeah, Indigo, which is now Sonovox, I believe, which could be something else by now. I haven't really looked into that either, but it's an old Indigo amp. I know a lot of people, you know, bash Klipsch. Oh, you know, their subwoofers suck. They don't last. Well, I hate to tell you, but it's not Klipsch. It's the amplifier manufacturer. They just happen to use them. All right, 47 at 50. I placed an order for some caps to come in, and it was like 2 weeks ago. They're still not here yet. I don't know what's going on with that, but I'm starting to get low on some of my common parts again. I need my inventory to get refilled. And make sure you check the polarity when you're popping the caps back in. On this specific board, the square pad is positive, and they also have a negative mark on the board. Check and triple check your polarities. Otherwise you'll boil the caps, and that's never a good time. think this one actually lifted a pad. I gotta cut that and check it out, but I think it, actually what I'll do, since it looks like it's just a short trace, I'm gonna cut the trace long, and I'm gonna use the trace to bridge the gap. But it looks like it lifted. Still making an electrical connection, but I'm gonna fix that anyways. Yeah, the corner lifted. It's not a full lift. I don't know if I can blame the I don't think I can blame the solder sucker for that. Maybe, but either way, it's going to get a little permanent fix right here. I wouldn't feel comfortable sending it back with the partial lifted pad. I don't think it would hurt anything, but I'm a little bit of a perfectionist, so I want to make sure that the repair is the highest quality. Clean this guy out too. It's hard working with these real short lead lengths sometimes. So what I'm doing is I'm just popping that right down over the old trace. And then just bending it around until it meshes with the next connection point. And then I'll just solder it back in. So now I know it won't go anywhere. It's making connection. The through hole still appears to be in good shape, so it didn't damage the through hole. So a little bit of a bodge, but I don't think that hurts the integrity of the repair at all. And it's got a nice top solder fillet on it, so just better to be safe than sorry on that one. And part of the problem is the rings that they put on these pads are so small compared to the hole. If they would have made the rings where the solder goes just a little bit bigger, they would be, you know, much stronger. You have a lot more area to stick to the board. And I mean, they're not really cramped for space that much on here. There's a lot of room on there. I always usually try, when I'm making a circuit board, try to make the ring 2 times the size of the hole. And never have problems with pads lifting off. This is an old board though too, so you know I got to keep that in mind. The newer boards have much better layer adhesion and everything because they're just using better materials. So that is part of it. Let's see, these are hundreds at 25 volts, 2 of those. Bent the leads real good on that one. 100 at 25. These are the main filters for the plus minus 15, which feeds all the op amps. So having good caps in this spot right here is fairly important. You want to make sure your op amps get nice, clean power. Sometimes you got to turn the board over to get the solder to flow down through. I like to make sure I can see the solder on the other side of the board. So sometimes using gravity as a cheat helps you out a little bit. It's another one of them tight squeeze areas. The caps are just sandwiched in there right up against one another. I've been doing a lot of board layout lately at work. It's not even what I'm supposed to be doing, but we don't have anybody to do it, so I've been kind of picking up the slack. And you know, one of the things I always check is the clearances for the parts to make sure everything can fit in there. I don't understand. I mean, they have rings around all the caps. They know how big they are. Why make all the parts overlap? There's plenty of room to just shift stuff around a little bit and make it fit in there nicely. I don't understand. Need to talk to like somebody that does PCB layouts for a living and really figure out, you know, why certain boards are laid out the way they are. I don't get it. Alright, last two. And then we got to put the big cap in. Some of this lead-free solder just does not want to come out. I think that's part of the reason for board damage too. Lead-free solder has a much higher melting point than leaded. So it does not play anywhere near as nice as the old stuff. These should be 247s if I can get them out. And since I'm only going to be doing the power supply tonight, let's get a reading on one of these. Maybe we'll read a couple of them. They're probably good, but it doesn't hurt to check them out. Okay, I spoke too soon. Alright, let's try that again. This is supposed to be 47. And we're getting 16. So this is why you need to recap your amplifiers. And I know I've gotten a few comments from people. All you do is just recap. Well, if that's what the repair requires, that's what I do. These 100s are well out of tolerance. It's reading 80. This guy reads. That one's supposed to be 100. It's reading 74. I'm just going to test all of them, see if I have any good ones in here. That one's supposed to be 47. It's reading 37, 38. Out of tolerance. Same thing. Yeah, these, I mean, these are all bad. Every one of these caps was pretty much on the verge of death. That 47's reading 25, so definitely time for new caps. Let's compare a brand new one. 47, 50 volts. I just want to double check something real quick. Make sure I didn't put a 4.7 in there because my 4.7 drawer was open. Sometimes I do boneheaded things. I think we're good. I think we're good. Alright, 3 more caps and we can power this thing on. And I will test one of these. I just want to get one of them stuck in there. So this is a brand new Litecoin cap. $46.4. That's a lot more like it. I think these are 10%, so there's plenty of wiggle room. Alright, check your polarities because they get a little funky in the center here. Alright. Let's solder our last couple of caps in. I'm going to tack the outer legs of each one and then straighten them out to where I'm happy with them. There we go. I don't bend the leads on these. I know there's people that probably will. It's just not my style. I don't like doing it. One, it makes it harder to get them out. Two, it potentially causes damage to the board. And three, there's absolutely no reason for it. Nobody can tell me that there's a justifiable reason to I'm just hitting them with the solder sucker just because it leaves a little bit better of a fillet on there. You don't have to do that, it's just more of an OCD thing. Alright, what's our last one? 470 at 200. 470 at 60, 470 at 200. I'm running low on these guys too. I only have skinny ones, which is fine. A little bit taller than the old one. If you're in a pinch, you can always upgrade these. You can throw a 560 in there. You can even throw a 680 in there. You could really throw 1,000 in there too if you wanted. It's getting a little bit into the overkill range, but you can go up on the value on these guys if you have something or you don't have something. I keep it stock because it's just what I do. You know, if I'm doing my own equipment, then I get kind of crazy and experiment around. But since this is not mine, he's gonna get what it came with. But with the larger cap, you depending on how the amplifier's set up, sometimes you can get a little more punch out of it. Just because there's a little bit more juice on the rails. Not always the case, but sometimes. Alright, I think we are good to go for a test. everything is in. Polarities look good. The known bad parts were taken out. Let's see if we get our 7 or 8 volts on our output side. No promises, but let's see what happens. Make sure our power is off so I don't get zapped. Shut my soldering equipment down. I still hate these insulated terminals. I know they're safer to use, but the cheapy open ones that I had on there were so much nicer. They just slid on and off way better. Alright, let's get rid of the parts we don't need. And we're going to power on current limited, but we're... Can you guys see that voltage? Probably not. Now you can. There we go. Thank you, Mr. Capacitor. Alright, let's see what we get out of the CD plus and CD minus. We should get our voltages if nothing else is wrong. We're going current limited. Never go full supply on directly into the board without a fuse. That's just dumb. Current limited. Okay, so it's showing dead short. So I turn the switch on. My light bulb goes full brightness. Full brightness means we have dead short. That's why we go current limited. If I would have went just raw power, I would have blown the breaker and everything would have went dark. So I'm gonna pretty much guess that it's one of the MOSFETs that's failed shorted. And that's what it's reading, but which one is it? Gotta take them both out. Hopefully we still have, yeah, we still got some heat left and it'll only take a minute to heat up. But yeah, that happens. What can you do? You know, it was blown pretty good. I still think it was a surge or a spike that caused that. That is my guess. I don't know what if is Canada 220 power or are they 110 or both. That could make a difference. What's this thing set up for? This does not have a voltage selection on it. So it's got to be 110, 120, whatever the nominal number is, 117. That's what my line voltage reads, 117. There's no easy way to replace these. Unfortunately, you just have to take the whole heatsink has to come out carefully. Alright, let's find our short. This one passed high pot function burn-in after burn-in, but it didn't pass air leakage. Interesting. Oh, look at that. We have the rare case where both FETs are completely destroyed. That don't happen too often. This thing must have got hit pretty good. Maybe it was a lightning spike. Cool. I mean, not cool for me because that's another $8 in parts, but still cool. Alright, let's get this thing off. It's got a ton of It's not glue that they put on it. I don't know what the heck this stuff is. It's like some sort of a melted plastic that they put over the screws. Sometimes it's really hard to work with. Today it's going to be really hard to work with. Well, maybe not. Hold on. Can I get it out? Come on. Get out of there. Oh, I came out. I got lucky. I got super lucky. Not always that lucky. There's a good chance that the control board is also totally destroyed. I won't know that until I get these replaced. These are 17N40s. And I have some of those, I think. I just gotta find them. Geez, I only have 2 left. Just getting my last 2. No, wait, I got 2 more. Still, I'm down to my last 2. I gotta put those on the order list. I will be shut down if I can't get my parts. Put just one little speck of thermal paste on there. I'm not cleaning off the old heat sinks, one, because the excuse me, the thermal paste is still soft on them, and 2, I need to know where these devices were sitting. These are not the ones that have the screws that go through the heat sinks. They use this little bar style clamp on them, so it's hard to get them lined up. So it's better if you can go off the old markings and just kind of get it as close as you can. You don't need to go nuts with the clamp, you know, good and snug, just enough to hold it onto the heatsink. You put it too tight, you're going to crack the ceramic. I like how that's sitting. I'm going to put silicone in there, and it's going to go all over this like head of that screw, so I'm not going to worry about putting anything on there to hold that at this point. Otherwise, I'd put a drop of E6000 on there to hold it. But since I want to silicone that cap in place, I'm not going to worry about it. Alright, my screws are not going in, which means that my devices are way off. So they both have to go that way a little bit. Now I could be way off. There's no easy way to do this though. Like, they're not centered, so I can't check it from the bottom. You just everything's guesswork. It's difficult. It's difficult when you're trying to reset these up. This is one of those no free lunch scenarios. So you just gotta eyeball it, hope you got it close, screw it down, try it. If it don't work, try it again. Until you get it right. Should be good this time, I think. One thing I am going to check while I have it out. No, I'm actually not. I was going to say I was going to check the gate drive resistors, but the gate drive resistors are actually on this board, where there are no gate drive resistors on this. That's weird because usually you don't see them on the board, but legs were a little bit tight. I should be able to make that work though. But I can't get in and adjust the screw. It really needs to come. Yeah, they need to come a little bit more even. I'm really close to the edge of the heatsink. Let me just try and get these in there, get the screws in before I move them again. Oh yeah, that's good. We're good. Screws are going in. Always screw before you solder. Always, 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 always. You will destroy the devices if you don't. And make sure you get both both screws in before you tighten it down too much. Alright. Those don't have to be really tight either. Let's solder them up and try again. Hopefully our control board is good. I'm going to hit these large spots with the larger tip just from the side. Just want to make sure I get good flow down in there. And you'd be surprised, it does make a significant difference being able to get more heat in there. Okay, solder joints look good. I don't have any bridges. Although there's a little booger on this one I don't like. Whisker. Okay, let's try again. This time with success. Shut off my soldering stuff. Let's get my voltmeter and my kickstand. Let's see what we got there. Alright, again going on current limited. Let's see what we get. Boom. There it is. 7.8988 volts. This power supply is in business. Let's see what we got on our 15. We can go back on and just double check. Just be careful you don't cause any shorts. Plus 15. And we should get plus 15 going the other way too because I moved the positive over. Between the two we should get 30. There we go. Power supplies are alive. Well, let's see. Yeah, it's way past 12, so I am going to call it there. So we got the power supply section up and running on this. I got a little bit of a late start. I don't want to stay up too late tonight. Um, but the power supply is back in business. Tomorrow I'll do a part two and we'll finish the digital board and the amplifier board, and we should be able to get this thing back up and running and get it back on its way home. So I appreciate the comments and you guys watching. Please remember to like and subscribe, and I'm gonna go get some sleep, and I'll see you tomorrow. Have a good night.